Okay, welcome back. This is the first video for balancing reactions. And what this is going to be in the first part is going to be our notes. So if you have notebook and if you have the packet, please get both of those two things and we'll be referencing those as we go. Okay, so we're going to start off by talking about what is a chemical reaction. A chemical reaction occurs when you have a set of reactants that will quote-unquote react with each other, being mixed together. The reactants are always going to be on the left side of your equation. So over here we have hydrogen mixing with oxygen and it's making water. So on the left side we have our reactants, stuff that is reacting. Then to show that something is formed, we give it an arrow or a yield sign. And then on the right side, we'll have our products. So in this case, hydrogen and oxygen are reactants and water is our product. Some of the things that can affect a reaction, number one is heat. So heat can oftentimes speed up a reaction, and a catalyst can also speed up a reaction. Now what's different between those two is the heat will be consumed in the reaction, but the catalyst is never consumed, it's just kind of there hanging out, and helps the reaction speed up. Next thing we have is states of matter. So any one of these participants in the reaction can have a different state of matter. So the ones we have here are S for solid, L for liquid, G for gas, and AQ for aqueous. And aqueous, let's write it down here because I don't have it spelled out. AQUEOUS, and this just means that it is dissolved in water. So for most of these reactions, if we have anything that's aqueous, it's going to be in water. And what happens when you put salt into water? It dissolves, right? So that's just a way for us to show that we still have the sodium, we still have the chlorine, it's just going to be dissolved in the water. So we just have ions hanging out in solution. So that's what that is. Okay. Precipitate is going to be any solid that is formed from a reaction. So that's just a fancy word to say what was created that is a solid. So if we had iron that was created from a reaction and as a product, it would be also called a precipitate. So it's another word for the solid that is formed. Now when we look at our reaction and we want to show that heat or a catalyst was used, something like that, that's going to happen above the reaction arrow. So if we want to show that heat was added to the reaction, we would give it a little delta triangle on the top, and that'll show us that heat was a participant in the reaction. If you want to show that any type of catalyst was used, you would just write the catalyst name above here. So if you have a platinum catalyst, I would just put PT on the top. Okay. And then again, when we have states of matter, you would just put those at the end. So solid, liquid, gas, and aqueous would go there. Okay, so that is the basics of what a reaction scheme looks like. Now we're going to get into what we're going to do to balance reactions. And the biggest thing we have to take into consideration is that we had to conserve mass. So in any type of chemical reaction, you have to have the same number of elements on each side of the equation. Can't lose them, can't gain them, we're not poofing them into space, whatever. We have to have the same number on each side. How we balance reactions is we use a coefficient, and the coefficient is a number that's placed in front of each chemical formula to indicate how many moles of each are needed in that reaction. Now all that we're doing is adding a whole number in front for the most part in order to balance out between the same number of elements. So first example that we'll do with this is, let's say we have sodium and we are going to add that to chlorine. And then that makes salt. Okay, now for this we need to first count up how many of each element we have on each side. So what I like to do is I like to go down here and I say, okay, I'm going to write down my elements that I have. I have sodium and I have chlorine. First step to do is we're going to count them. So how many sodium do I have on the left side? I have 1. So I'm going to write a 1 down here because that shows you how many I have. Next I'll go to chlorine on this side. I have how many? 2. So I'll put a 2 there. Onto the right side. So sodium I have 1. And chlorine on this side I also have 1. So this is sort of keeping a tally of how many of each element that I have. So my goal is so that both of these are going to be equal, right? So I need to have the same amount of element on each side. Now, in order for me to balance this, the only thing I can do is place a coefficient in front of each of the elements. When I do this, I am multiplying. I am multiplying that coefficient by whatever the element is in front of it, or behind it. So, my options are multiplication. So let's go down here and look at our elements. I have sodium, I have 1 on each side. Is that balanced? Yeah, so we're good. We don't have to do anything. Let's go down to the chlorine. I have 2 on the left and 1 on the right. So that's not good, right? That's not balanced. So what can I do to balance it? So in a sense, I have to make them both equal 2. And remember, I'm only using multiplication. So what can I multiply 1 by to get it to equal 2? Well, I have to multiply it by 2. When I multiply the 1 by 2, I get 2, right? So then that makes the number of chlorines we have balanced. When I multiply by 2, I have to bring that coefficient into the space in front of the element or the compound, whatever we have. So that forces me to put a 2 in that space. Okay. Now, when I put that 2 there to balance the chlorine, I also made sodium 2. So for then, I have to go back and apply the changes I made. I'm not just multiplying by 2 because I did that on the right. It has to be with the element. So this 2 goes to the sodium and it goes to the chlorine. Because that 2 is in front, I had to do it to both the sodium and the chlorine. Just because I multiplied on the right side doesn't mean I have to do it for the entire side. Okay, so you're just looking up here to see what is that 2 distributed to. Now, because that 2 was distributed to the sodium, I have a mismatch here. So I have to go on the left side of sodium and multiply that by 2 to get it to equal 2. Now, when I look at my equation, I have 2 sodium on each side and I have 2 chlorine on each side. So they both balance out. So that's how we know it's good. Okay, and remember for this we can only use multiplication. One more. So if we have arsenic plus chlorine makes arsenic chloride. Okay, well, my plus side's a little wonky, we'll live. Okay, first step, we're going to count the number of elements on each side. So I have arsenic, and I have chlorine. Okay, how many arsenic do I have on the left? I have 1. How many arsenic do I have on the right? I have 2. How many chlorine are on the left? I have 2. How many chlorine on the right? I have 3. Okay, so they're all right in my coefficients. So, nothing is good here, right? We have 1, 2, and a 2, and a 3. Doesn't work. What I recommend to do when balancing out equations is always start at the bottom, or always start with the most complex thing. The most complex thing is right here with our arsenic chloride. So we're going to try to balance that out first. And we'll always start with the anion on the end. In general, you don't have to start there. It's just a habit that I have. So if we look at the chlorine first, we have 3 chlorine on the right and 2 on the left. So what can I multiply these by in order to have them equal? So between 2 and 3, we're looking for a least common multiple. So the least common multiple most of the time is whatever it is multiplied by the other number. So between 2 and 3, the least common multiple is 6, right? So in order to achieve 6, we have to multiply 3 by 2 and 2 by 3. So what I like to do when I see chlorine 3, chlorine 2, I just say, okay, I need to multiply by the opposite number. So I need to multiply this by 2, and I need to multiply this by 3. and that balances it out. So that gives us our 6 on each side. And again, where did I get that 2 from? Right here, and this 3 comes from right there. Okay, now we can look at our arsenic. And arsenic's easy to balance because the arsenic on the left doesn't have anything attached to it. It's just one arsenic. So that gives us a lot of freedom. So when we look over here, this 2 is distributed to the chlorine and to the arsenic. So we have a 2, and there's already a 2 here. So what's going to happen? We're going to multiply 2 by 2 to equal 4. We have 4 arsenic on the right, so what do I have to put on the left? 4. Okay, so we end up with 4 arsenic on each side and 6 chlorine on each side. So we're done. Okay, so that's the basics on how to balance equations. We're going to be doing each type of reaction individually in separate videos. So that's just the basics how to do it. Remember, you have to remember we're only using multiplication with this, and we're adding numbers in front. All we have to do. Okay, so let's take a look at our packet. So this is the balancing reactions packet that we have. On the front, it goes over a lot of the same stuff we've talked about already. So looking at chemical equations. This is called a chemical equation because the number of atoms on the left side of the arrow is equal to the number of atoms on the right side. So this is already balanced. The arrow is used to indicate the substances on the left have changed to form the substances on the right during the reaction. And the equation, a number appears before the hydrogen molecule symbol and the water molecule symbol. This simply tells how many of each kind the molecule is involved in the reaction. As before, 1 is not written in front of the elements and compounds, but it is understood it is there. In the above example, number 1 is written for the symbol of the oxygen molecule, but is understood to be there. So there's no 1 here, right? But there has to be one of them if we wrote it. So we just don't write 1. If we look at, in general, the left-hand side of the equation is called the reactant side, and the right hand is called the products. So the left-hand side will always be called the reactants, right side is the products. In the reaction above, up here, what are the reactants? Well, we know the reactants are the things on the left. So our hydrogen is going to be a reactant, and our oxygen is going to be a reactant. The product is what? Well, what's the only thing on the right? Water. Okay. Moving down forward, we're talking about states of matter. So additional symbols are often used with chemical equations to describe the application of heat, which is the delta symbol, and the formation of a precipitate, which is a solid. A precipitate is the name given to a solid that forms in the reaction. The formation of a gas, which is G, in the presence of ions in water solution, is aqueous, which means water. So below are some examples containing that. So with this, it asks, in these reactions, the gases formed are what? So we were going to look for gases. And we'll have to look at gases that are formed. So if they're formed, they have to be on the right side of the arrow, right? So SO2 is formed and CO2 is formed. Why didn't I say oxygen? Because it's part of the reactants. It's not formed from the reaction. So it's just SO2 and CO2. Precipitate that is formed, you would have AgCl and CaO as precipitate. Ions in water solution are what? Well, what's in solution? That's aqueous. So we have our silver and our chlorine here. Okay, so being able to identify states of matter is great too. So that's everything for just the basics of a chemical reaction, and I showed you how to solve some simple reactions. In the next video, we are going to go back to balancing reactions. There's 5 types of reactions we're going to be doing, and we'll start there.